Hello, my dear students. Welcome to my channel Physics by MKR. Today, we are going to discuss the concepts of vector. So, first of all, what is a vector? Primarily, physical quantities are divided into two categories, namely scalars and vectors. The common property of scalar and vector are magnitude is the common property and vectors additionally possess direction. Hence, a vector is represented as the magnitude multiplied with the direction. For the purpose of direction, we are introducing unit vector whose magnitude is 1 unit and its direction is same as the original vector. For example, if you take a bar as a vector, its magnitude is a and its unit vector is a cap. So, a cap is the unit vector in the direction of a bar. Similarly, b bar is equal to b multiplied with unit vector b cap, where b cap is the unit vector of b bar. In this way, every vector will have its own unit vector in its direction. But as a common unit vectors, I cap, j cap, and k cap are selected as common unit vectors along x, y, and z axis with reference to a coordinate system. Suppose if the vector a bar is along x axis, we can represent a bar as a into I cap instead of a into a cap. Because its direction is along x axis, its unit vector is I cap. Similarly, b bar is along x axis, it is also represented as b bar is equal to bi cap instead of b into b cap. So, in this way, any vector along x axis will have a unit vector as I cap. And similarly, any vector which is having direction along y axis will have unit vector j cap, and any vector along z axis will have unit vector k cap. A vector is geometrically represented by a directed line segment with the initial points A and B. Initial position is A, which is also called the tail of the vector. Final position is B, which is also called the head of the vector. The distance between the initial and final positions represents the magnitude according to a scale, and the arrowhead represents the direction of the vector. This is about geometric representation. And about the components of a vector. A vector can be resolved into any number of components. There is no limit for it. But what do you mean by a component? The projection of a vector in a preferred direction is called its component. And it is the product of the magnitude of the vector and the cosine of the angle between the vector and the direction. For example, a bar is the vector. And I am preferring three directions here, OQ, OR, and OS. Making angles alpha, beta, and gamma with the actual vector a bar. Now, this vector is resolved into three components. Along OQ, the component is A multiplied with cos alpha. And along OR, it is A multiplied with cos beta. And along OS, it is A multiplied with the cos gamma. The rule is the sum of all the components, the vector sum of all the components must be equal to the given vector. That is the resolution of vector into components. Therefore, A bar is the sum of A cos alpha plus A cos beta plus A cos gamma. In this way, you can extend it to any number of components. And a vector cannot have a component in a direction perpendicular to it. That means If A bar is represented along OP in a direction perpendicular to this, the angle is 90. Because cos 90 is 0, this A cos 90 is 0. That means a vector cannot have a component in a perpendicular direction to the vector. If vector A bar lies in xy plane, it can be resolved into two perpendicular components, which are also called rectangular components, because those components represent the sides of a rectangle. That means the angle between two adjacent sides is 90 degree. That's why these components are also called rectangular components. Here, A bar lies in the xy plane and makes an angle alpha with the x-axis, beta with y-axis, whereas beta is nothing but 90 minus alpha. Now, the x component of A bar is Ax is equal to A cos alpha, and y component is Ay is equal to A cos beta. Component is always represented by cos of the angle. But here, beta is nothing but 90 minus alpha. That's why it is A cos 90 minus alpha, which is A sin alpha. Hence, the sum of the components is equal to given vector. That's why A bar is equal to Ax I cap plus Ay j cap, which is also A cos alpha I plus A sin alpha j. Here, modulus of A bar is represented as root over Ax square plus Ay square according to Pythagoras theorem. Hypotenuse square is equal to side square plus side square. This is that. A bar is representing hypotenuse and Ax and Ay are two sides of a rectangle triangle. That's why the magnitude is equal to A is equal to root over Ax square plus Ay square. And here you can measure the angle alpha with cos alpha is equal to adjacent component x component by total vector modulus, and sin alpha is equal to and y component by modulus of A, and tan alpha is equal to y component by x component. So in any way you can measure the angle alpha. If A bar lies in yz plane, then you can represent A bar as Ay j cap plus Az k cap. And if it lies in xz plane, A bar is equal to Ax I cap plus Az k cap. Here, an important question is whether the component of a vector is a vector or scalar. The answer is the component of a vector is undoubtedly a scalar. But the vector component of a vector, if it is specifically mentioned as vector component of a vector, then it is a vector. That means component of a vector is a scalar, but vector component of a vector is a vector. If the vector lies in space, like along OP with respect to a coordinate system like this, it can be resolved into three mutually perpendicular components, and they are also called orthogonal components. One along x-axis, another along y-axis, and another along z-axis. For that, the angles made by the vector A bar with x-axis alpha, with y-axis beta, and with the z-axis gamma. And as usual, the x component is A cos alpha, y component is A cos beta, and z component is A cos gamma. And they are represented like this. Ax is equal to A cos alpha, Ay is equal to A cos beta, Az is equal to A cos gamma. And the sum of all the three orthogonal components is equal to the given vector. A bar is equal to Axi plus Ayj plus Azk. And the modulus of A bar is given by root over Ax square plus Ay square plus Az square according to Pythagoras theorem. And the value of cos alpha is as usual ax by a cos beta, ay by a, and cos gamma, az by a. So is that if you square this, a square is equal to ax square plus ay square plus az square. And the relation between these three cosines are called directional cosines because they are representing the direction of the vector a1. That's why the relation between these directional cosines is given by adding the squares cos square alpha, cos square beta plus cos square gamma is equal to ax square by a square, ay square by a square, az square by a square. By summing all these things, you will get ax square plus ay square by plus az square by again ax square plus ay square plus az square, which is equal to 1. So the relation between the direction of cosines is represented like this: cos square alpha plus cos square beta plus cos square gamma is equal to 1. The advantage of this formula is if you know two angles, you can find the third angle. This is the useful relation in determining the angles. And if you want the projection of this a bar in the xy plane, that means you are taking only two components, x component and y component. Then this is axy is equal to root over x square plus ay square. The projection of a bar in yz plane is again root over ay square plus az square. And the projection of a bar along xz plane is root over ax square plus az square. Projection of a bar along x-axis is ax, along y-axis is ay, and along z-axis is az. So this is all about the components of a vector. Finally, a vector can be resolved into any number of components, but the sum of all the components is equal to the given vector. And if a vector lies in a particular plane like x, y, y, z, and xz, it can be resolved into two rectangular components. And if a vector lies in space, it can be resolved into three perpendicular components or orthogonal components ax, ay, and az. And another important thing is you cannot have a component of vector in a direction perpendicular to it. Thank you for watching my videos.